All right, now we're going to look at concentration. By what I mean by concentration is how concentrated, how dilute, or whatever. Instead of saying, there's a little bit in there, or there's a whole lot in there, or it eats through your skin, or something like that, you can actually calculate to a numerical value the concentration of a solution. And it can be per volume, it can be grams. There's a different, it depends on what you're looking at. The most common with like normal chemistry, medicine and stuff is what they call molarity. And then there's also percent mass. So I'm going to show you a bunch of different ones to show you, again, this is where you can come up with a numerical value of the volume or the concentration. And again, it's solute per volume. That's concentration. So it's an actual number, not just like there's a whole bunch. Okay. So it can be measured using calorimetric methods or quantitative. In most cases, we use quantitative. Okay. Calorimetric would be you run it through a machine and it reads the amount through a series of colored tubes using electromagnetic spectrum. And we're not going to do that. We're just going to do it quantitative. We're going to actually determine it by multiplying and dividing. Okay. The unit of concentrations, again, vary depending on what you're looking for. Are you looking for mass? Are you looking for moles? Are you looking for volume? It just depends on. So there's different units. They're all kind of doing the same thing. They're trying to find concentration, but your final answer, it's going to depend on what you're using it for. Okay, we can do concentration as a ratio of mass to volume. Okay, that would be molarity. Percent mass to volume, that's percent mass. Moles, again, we got to switch things to moles, to volume. Oh, there's your molarity, sorry. And then equivalence. Equivalence is how many hydrogen hydroxide, and again, I'll show you those later. So again, there's all different kinds of ways of doing concentration. Okay, when you make up a solution, you can use one of these things. They're called volumetric flasks. You put the amount that you calculate in the flask, and then you add water, and you can see there's a little line right here. If you fill it up to that line, then it'll be of a certain molarity. Each of these flasks has a different one. My suggestion, though, is I always add a little bit of water in here, shake it up and dissolve this, and then finish up, because if you add it to there, then you can't really, mix it as well as you'd like. Okay, so volumetric flasks are used to prepare solutions of specific concentrations. And you don't have to use one. You can use, you can use a beaker or whatever, but these are, when you're really doing research and it has to be exact, these are what they'd use. Okay, so when we're looking at concentration, again, mass per volume is like when you do your blood solutes. Okay, when you get thing back of your blood work, okay, they're going to give you certain things, and it's usually milligrams per deciliter. Here they're talking your fluids besides just your blood, like your plasma in your blood, as actually 0.9 salt solution. Okay, a little less than 1% is salt. This is what they normally are. So when they give you, like when you have to get fluids, when you have to get an IV, this is what they give you, 0.9%. That's called saline solution. If they give you more than that, you're going to have problems. You're going to become more dehydrated. If there's less than that, it's not really, you need to replace your electrolytes. Sometimes they only give you a 0.545. Maybe if you have like a blood heart condition or whatever, they'll get it down. Dextrose is if you need energy, if you need sugar. Dextrose and sugar, like glucose, are the same thing. So they have different things that they can give you depending on what's wrong with you. Here you can see Ringer's lactate, a little less on the salt. They add another type of salt in there, and they give you some electrolytes, potassium chloride, calcium chloride, again. And I think if you add these all up, they're really close to, less than 1%. Okay. So again, it just depends. Mass divided by volume concentration. When they're doing an IV solution, they use these concentrations. They take the grams of the solute divided by the milliliters of solution. And then to change it to percent, they multiply by 100. So again, this is a common thing to use in medicine. Okay. The nice thing for you, usually, like if you have to use it, you usually don't have to make it. Usually it's made for you and you just hook it up to the machine. But maybe you're going to be a pharmacist and you'll have to make up those solutions. Okay. So mass divided by volume, there's parts per million, parts per billion. Basically, once you get your grams of solid over your milliliters of solution, that's percent by mass. Okay. Then if you want to change it to parts per million, you multiply 1 times 10 to the 6th. If you want to do parts per billion, 1 times 10 to the 9th. Okay. And this is common things to do with medications. Okay. They dilute them to that point. Okay. Okay. Here's an example of a percent by mass. Okay. Find the percent by mass of a solution. Okay. We have 34 grams of salt dissolved in 400 grams of water. Now mass Percent mass is mass of solute over mass of solution. Here they give me the solute and the solvent. So I'm going to take 34 and then I'm going to have to divide by these two added together because the mass of solution is the solvent and the solute added together. Okay, so I take 34 and I divide it by, I take 400 plus 34 because this is the mass of my whole solution. If it said in 400 grams of solution, I wouldn't have to add them together. But it doesn't. They list them separate, so add them together. So take 34 divided by 434, and you get 0.078, and then you move the decimal over 2 or multiply by 100, whichever is easiest for you, and you make it 7.8% salt. So this solution is 7.8% salt, and the other 91.2% is water. This would be an extremely salty solution. Okay, you probably couldn't even drink it. It'd be nasty. Okay, if you wanted to change it to parts per million, take this, your 0.078, and multiply by a million. So if you had a million parts, this many would be salt and all the rest of them would be water. If you want to do parts per billion, take 0.078 and multiply by a billion, or 1 times 10 to the negative 9th. You could do that too. And again, this is how many parts would be your salt in a billion. If you had a billion balls, this many balls would be salt and the rest of the balls would be water. And that's how you'd change them. It's actually pretty simple. Parts per million, multiply by a million. Parts per billion, multiply by a billion. Okay? All right, so if you're looking, another type of, and this is a real common one in chemistry. This is like the way of expressing concentration in chemistry. It's molarity. And it's moles of solute per liter solution. Okay? Like when I order kits, I order if I have to order some solutions or make them up, I always have to do molarity. Okay, if you have a blood test done, it's usually millimoles per liter. Okay, so it's 1,000 times less. Okay, and they have equivalents here. When you're looking at equivalents, you guys, it's just whatever their charge is. See how sodium's +1, potassium's +1, hydrogen's +1. If they're +1, they have 1 equivalent. If their charge is +2, then they have 2 equivalents. If their charge is +3, they have 3 equivalents, and so on. And if it's a negative, same deal. Okay, so if you're looking for equivalents, because some tests you have to divide by the equivalents, then you would just use their charge. Okay, and again, that's what I just want. That's how many electrolytes you're going to get. Okay, so if I'm doing electrolyte solution, these guys are going to provide 3 times as many ions as these guys, because it's 3 to 1 as far as equivalents. Okay. And again, equivalents per liter are calculated by multiplying the molarity by whatever their equivalent is. Okay, so again, that's when you're looking at electrolytes, you're going to add, because you're going to get twice as many ions. If you dissolve sodium versus calcium, calcium is going to have twice as many ions as sodium. Okay, so we're going to find molarity. Molarity, again, this is the most common way of doing concentration in chemistry. Molarity is moles divided by liters. Okay, I have 45 grams of calcium chloride and I have 400 milliliters of water. I don't have anything. I don't have moles and I don't have liters, but I can switch these easily. First thing you do to find moles is you take the mass that they give you and you divide by its formula mass. This is 1 calcium and 2 chlorine. And again, if you have that app on your phone, you'd put in calcium chloride and you get 111 grams. Okay, so you divide those two first, and this is your moles of calcium chloride. It's the mass they give you, divide by its formula mass, how much it weighs. Okay, then to get liters, well, I got milliliters here. All you have to do is move the decimal over 3. Or you can, divide by 1,000, whichever works best for you, but I just go, the decimals here, I go 1, 2, 3. So 400 milliliters is 0.4 liters. Now I got all the information. I got moles, I got liters. So I just take my 0.405, I should have written moles in here, sorry guys, divided by 0.4 liters, and the molarity of this solution is 1.01. Okay, so molarity is moles divided by liters. Usually give it in grams, divide by its formula mass, and you'll get moles. Liters, if usually it's milliliters, move it over 3. If it's in liters, you don't have to touch, you just divide by it. But usually they give it to you in liters, so you just move it over. Okay? Okay, how much, now what if we go the opposite way? What if you have to make up a solution of a various molarity? And again, this is the most common thing I have to do. If I make up a lab, it's going to say, okay, you need 350 milliliters of lithium fluoride and its molarity should be 0.5. Okay, so now I got to go backwards. So First, I know that molarity is moles over liters. So if I take molarity times liters, I get moles. Okay, that's step number one. So I take my molarity, 0.5, and then I multiply by, I need 350 milliliters, so I make it 0.35 liters, move the decimal over 3. This is how many moles of lithium fluoride I need. I don't know how to measure out 0.175 moles of lithium fluoride. I don't have a mole meter in my lab. There's no such thing. I just made that up. So what I'm going to do is I need to change this to grams. Okay, so I'm going to take 0.175 moles of lithium fluoride, 1 mole in the bottom, cancel it, and this is its mass. This is what lithium fluoride, because fluorine's 19 and lithium 7, add them together, you get 26. So then I multiply. Now I got everything I need. What I'm going to do is I'm going to measure out 4.55 grams of lithium fluoride, which is a solid. I'm going to dissolve it in 350 milliliters of water, and lo and behold, I have my solution. I'll have 350 milliliters of lithium fluoride, and its concentration will be 0.5. So this is going backwards. The other way, you divide, this way you multiply, okay? And again, make sure you have these written down because you're going to need these for your assignments, okay? All right, another concentration if you're going to dilute a concentration. Okay, dilution is preparing a less concentrated solution. It happens a lot. You'll start with a concentrated solution. Maybe that's the way you found the equipment. That's a lot of times the way you order it, and you have to dilute it. Okay, most solutes are, we get what they call stock solutions. Okay, and common stock solutions are 1 molar, 2 molar, 3 molar. Okay, so I have a 3 molar and I need a 0.85. How do I do that? Okay, if you look at this, dilution equation is the concentration of what you started with your stock solution and how much you have of it, the volume, and then the concentration of your new solution times whatever volume you're going to add. So you're going to know probably these two, and you're going to know one of these, and then you can find the one you don't know by just manipulating the formula. Okay, so what is the new concentration of a solution if you add 15 milliliters of water to 8 milliliters of 0.9 molar solution? Okay, well, to solve this, I need the concentrations. Okay, I got one here, but I don't have the other. And I have the volume, so okay, to solve you need to multiply the original concentration by the volume of the solution. So I have 8 milliliters of 0.9 molar. And then I'm going to divide by the total volume. Okay, the total volume is going to be this plus this, because I'm diluting it. Okay, I'm adding 15 milliliters to the solution. I don't want to divide by 15. I want to divide by my total volume. These two added together. So all I have to do, excuse me, is take my original concentration times how much I have of it, 8 milliliters. Now I'm going to add 15 milliliters to it. So 15 plus 8, okay, this is my total volume, 33. So if I take this divided by this, I get 0.33 molar. And if you do this, you guys, and this number is larger than this number, then you know you did it wrong, because I'm diluting it. It has to be less concentrated than when I started to, because I'm adding water to it. That makes sense. If you have, you start with a concentrated and you add water to it, its concentration, its molarity should be less. So again, if you have this number and this number is larger, you did something wrong. Reevaluate. But really, all you do is take your original concentration times how much of it you have, and you divide it by how much you diluted. I added 15 milliliters plus the original. So instead of being 8 milliliters, now it's 23 milliliters. So I take this divided by 23 and I get 0.33. And that's my new concentration. And I think, yeah, that's it for today. Oh, we're just about done. That's it for this part of the lecture. We've got one more part to do. Okay, so now it's time for you to work on those problems. Go back and look at the examples I gave you. Plus I put some examples in the problems. So much for part 3.